Great, so thank you very much for joining us. Super excited to talk about this topic, which is something that I think is very cool about Rust, and so hopefully you'll get something out of this. I'm just going to say, just before we start, my main aim for this presentation is really to get people into traits. So if you're already somebody who knows about traits and feels very confident with them, this might be very basic for you, but and I won't be offended if you decide to drop off. But it's just literally this is aimed at people who've dipped their toe into Rust, sort of maybe have heard of traits, and want to get started. Okay, so the topics we're going to go through. So I'm going to talk about why traits exist, and really that comes down to the need for common functionality in our code. And I'm going to compare some of that functionality to other programming languages, particularly languages which use object-oriented programming. We'll talk about traits. We're going to talk about something called parameters, and then we'll go on to a couple of slightly more complicated, I would say more advanced concepts. And then finally, if you would like, there is a homework assignment if you want to dip your toe in further. It's obviously completely voluntary. All right. So defining functionality. So this is a very simple example, just one page of something that you could write in Rust. And so I have a strut. And a strut is, if you're coming from other languages, is like an object or a class in Python, and it has some information contained within that. So for example, for a circle, we would have potentially radius, and radius would be a floating point number. And I've just put it as an F64. Okay. Once we do that, say we want to calculate what the area of that circle is, we need to use pi, which we can just import from the standard library, and we can create this. We use this keyword imp and a function area, which takes in self, and then it returns another float. Okay, and then we can do our pi times by radius and squared. Okay, or radius. Okay, and if we do that, we get an answer. Okay, this is not using traits at all. This is just basic functionality. So we have our strut, and then we have some functionality that is implemented onto that strut. So we're combining information about the data, or say in this case circle, with some functionality. Okay, and for you, those of you who come from different programming languages, that will be very familiar. Okay, and we get the answer. Okay, but what we can imagine is this is something we might want to do more than once. And we have all different types of shapes in this case. And I'm just using shape as a very basic example, but this could obviously be expanded to lots of different things. Say we have another shape, and that shape is a square. Now, a square doesn't have a radius, it has sides. And if we want to calculate the area of the square, we need to do times the sides by each other. Okay, so just square it. Okay, and we can see that we've got if you look between the two, they're quite similar looking in the area, but they have different implementations. So what I mean by they're quite similar is they both are called area, they both take in a self, and they output a float, F64. And the same as here, but the actual implementation is different, but we're getting the same sort of input, the same sort of output. Okay. So say we want to make this efficient, and we want to say every shape, we should be able to calculate the area. Now, I'm going to use Python as an example, just because that's what I'm most familiar with, but you can do this in other languages. And I just wanted to demonstrate how you might do this in a different language. So really, it would come down to using objects and an object-oriented approach, where we would have a base class, like a shape, and we would say shape has got an area, and we won't actually do anything here. We'll just say it's going to have this this function. And in fact, you can decorate it with an abstract class, just to say any implementation of shape has to have an area. Okay, then we can subclass from shape into our circle and our square, and then we do the implementation of area here. Okay, so that's how you would do it for many object-oriented programming languages. And the key thing I want to point out here is to add that functionality, we're actually having to like go in and edit the class definition. So if you wanted to add an additional, additional functionality, perhaps we wanted perimeter or something like where it works out of volume. If it was in 3D, we would actually have to go in and edit the original class. Okay, and that is fine, but it can be it can get kind of messy, and it's very easy to forget to do it in certain classes, especially if it's one that you're not necessarily using all the time. Okay, so now we go on to Rust. So in Rust, we're going to use this thing called traits. So trait is a keyword in Rust, and I'm just going to define it as shape. Okay, so I have a trait called shape, and it has a function called area, which takes in self and it outputs a float. So that's that common thing that we saw before that was consistent amongst circle and square. So it takes in self, it uses area as the function, and it outputs a float. Okay, and then we use the imp word again, implementation, and we're saying for circle, that struct that we had before, we are going to implement this trait shape, and we are just going to add in this area and the information of how we've done it. Okay, so pi times pi squared radius. Okay, then we go into the implementation of the shape. And for square, and we do something similar. We do the implementation of the square area, and then we can run that and we get a result. Okay, so what is nice about this is we've essentially taken, I'm just going to flip back, we've essentially taken what we've done here, but we've just added a new bit of functionality. So we've just added a shape trait. Okay, and we've said a shape trait, anything which implements the shape trait has to have within that an ability to create an area, and that will take in some information and it will output a float. Okay, and if you look at this, we actually haven't touched the circle strut. So I haven't even put it onto the screen, but if you imagine above here, you have the circle strut, and it's exactly the same. We haven't touched it. Okay, we've just added functionality. We've added a new method. We haven't actually gone in and moved stuff around in the actual strut itself. Okay, and that is a real contrast to languages like Python, where you would need to define, you would need to, in the most basic way, you would need to alter the class, and that can create issues with it being messy. Okay, so the way that I think about this is it's like surgical inheritance. So those of you who come from other languages, you may be familiar with inheritance. That's that class thing I just showed you with Python. There are obviously other languages that do this. We're doing inheritance here. So we have a circle which inherits information from shape, square which inherits information from shape. Whereas here, what we're doing is what I call surgical inheritance, which is we're just defining the specific things that we want to share between the different shapes, the different struts, and everything else we're leaving. Okay, and you can actually have in traits, I've only defined one function here, area, but we could actually add more. So you could say anything which implements shape implements multiple functions. With me so far? Are there any questions about that?
No questions yet.
No questions. Okay. All right. So I just wanted to quickly go through object-oriented programming and Rust. So just to really hammer this home. So when you're using kind of a object-oriented approach, you have your data, okay, and then you have your behavior, and they are linked together. So certain bits of data has certain behaviors that can be applied to it. Okay, and this is, you know, it's getting into the nitty-gritties of programming, but essentially, like, this is an interface, and it allows us to define certain behaviors across similar sorts of objects. Okay, they essentially set a blueprint up, and you can use it in sort of many different ways. Okay, the nice thing about that is that you get a consistent interface, and that ends up being really important when you're dealing with big systems. But in Rust, what they've done is they have them separated. So we don't have that line around the outside. We just have the data, and we have struts or enums, which is like just a more, like, what is an enum? An enum is like a enumerated thing. It basically is like a subset of struts in this case. And then we have our behavior defined as traits. Okay, so they are separate, but they can be linked together or they cannot be linked together. Okay, and both of these mechanisms support something called polymorphism, and that just means that essentially you can, how to explain polymorphism? It's a flexible way that you can interact between different objects. So, for example, if you had something which took in a person object, and you had subclasses of like doctor and lawyer, it would, if you wrote a function which accepts a person object, it would also accept the lawyer and the doctor object. So that's kind of like polymorphism, basic example. And Rust allows us to use polymorphism in this really sophisticated way without changing the underlying class, which I think is extremely cool. Okay. And this just hats off to Maxwell, who works at Surreal and is one of my dear friends, who has come up with this diagram. And this is in his book, Rust and Web Programming. And I totally just screenshotted it for this presentation. Okay, cool. So now we're going to keep with our shape example. And we are going to create a new trait. And that trait is going to be called perimeter. Okay, it could be called anything. And perimeter is going to have a function called perimeter, and that is also going to output a float. And instead of doing it for circle, we're only going to implement perimeter for square. Now, we obviously could do it for circle, but just for the sake of this example, say we only care about the perimeter of the square. Okay, and so we do that, we just take the side, times it by 4, and that is our answer. Okay, so now we have a situation in which circle and square both have they both have the shape trait, which gives you the area of the shape, and square has an additional trait applied to it where we can calculate the perimeter. Okay, and this hasn't got really messy, so we don't have to do something strange with circle where we have to like pass in like a fake argument and pretend that it does have that ability. It's completely separate, and that's a separation of concerns, and that's really important for like keeping nice clean code. Okay, so we're essentially extending the functionality of square. Okay, so now we're going to go on to parameters. So I'm going to write a function called print area, and I'm going to do this. I'm going to ignore this bit for a start. Can you see my mouse actually when I'm pointing to things?
Yes.
Yeah. So ignore this bit for a start. But if we have a function, we're going to take in print area and we're going to pass it in a shape. Okay, and it's going to just print the area to the screen. Okay, this is like kind of bad practice because you would never really print in from a function, but let's just ignore that bad practice for now and say yes, our function is just going to print it. Okay, and in this case, because Rust is very heavily typed, we need to say what type of thing is shape. So, you know, we don't want it to accept, or in fact, it will just refuse to compile if you passed in something weird, like I don't know, a number or something, that didn't have this this area applied to it. So what we're going to say is we're going to say shape has to have T, okay? And T is just an arbitrary name that I've just chosen. So T for trait. And in these triangle brackets, we're putting in T implements shape. So what all this means together is this function will accept anything, any object or any strat which implements the trait shape. Okay, so that will mean that it can implement circle, and it can also implement it will accept circle, and it will also accept a square. Okay, so we can do that. I'm just going to do it for circle here. So we do the main, and we're setting up our circle with a radius of 10, and then we print it. Okay, and we get an answer. Okay, so now we're going to extend it. So we're going to say, and again, it kind of doesn't really make sense, but I'm just going to use it for this simple example. In our print area, we're now also, in addition to printing the area, we also want to print the parameter. And so we're going to extend this. So we keep exactly the same thing here. We're saying this shape, it has to implement this trait. And this trait, okay, this thing that we're passing in has to have shape trait, and it has to have perimeter trait. Okay, so that's really cool because it means that we can add multiple parameters, and it means that even though they're defined separately, they're implemented separately, we can combine them, and we can say this function is only going to accept something which can do these two things. Okay, and again, we're just going to print the area and print the parameter. So let's try that. We try it with square, and we get an answer, which are printed down below. Okay, but now let's try it with the circle. So if we go back, we remember that the circle doesn't have a perimeter trait. Okay, and so we would expect the compiler to pick this up, and it does. And one of the things that I'm constantly amazed about with Rust is how good the compiler is at actually telling you exactly what the problem is. And in this case, we get a very helpful error message, which is circle parameter is not satisfied. It's not implemented for circle. Okay, and yeah, it is pretty obvious and very helpful.
Caroline, just hopping in, we have a question from Michelle here. Michelle, okay. You've raised your hand. Do you want to ask it yourself, or do you want me to ask it? Waiting to see.
Should I stop sharing my screen?
If you could add. Oh, I'll ask it. Yeah, absolutely. So Michelle's question was, Caroline, you're using T as a general type, like an argument type T, or is this something completely different, as in just a variable, as it could have been anything?
It's I'm using it as a type. So I'm saying that shape has to, well, kind of a type. What's the best way of it? Yeah, it's like, is it a type? It's like type that implements these traits, if that makes sense. It's not type as in this is a string.
Okay.
Does that make sense? So like you could write this. So, you know, like shape equals, not equals, it has to be, I don't know, circle, for example.
No, it suggested maybe shape was a strut while perimeter is a trait.
Yeah, exactly. No, shape is not. So no, that's incorrect. So they're both traits. Shape is a trait, and perimeter is a trait. And we're saying we only accept objects that are cool, which have this trait applied to it or implemented, shape and perimeter.
Thank you. Thank you for clarifying that. Very good. And one extra question as well. Why do we have to pass perimeter separately? Shouldn't it be passed with shape?
No, because they're different traits. So if we go back to here, we've got shape here. I'm just using the square because that's the one which has got the parameter. You're implementing this trait shape Okay, and we could have called this something different, but just because it is to do with the shapes, we have this trait shape, and it has this functionality, and then we're implementing it just for square here. So now square has this trait shape applied to it or implemented for it. And then if we go here, we will see we also have a different trait called parameter, and it is implemented for square again. So they're two different traits applied to the same struct. Does that make sense? So then when we come to passing it in, we're saying T has to have shape trait and perimeter trait applied.
Perfect, thank you.
Or implemented. I'm coming from Python, so I keep using applied, but yes. Any other questions? No. Okay, that was a great question. So please keep them coming, and I'll do my best to answer them. Okay. So, oh yes, so I was saying about the compiler. So the compiler has caught that this is an error, so it won't even compile, and it will just say like circle doesn't have a perimeter. Okay. So, a way to make this clearer, because if you can imagine, if you have several different arguments, so these being arguments, shape here being argument, but imagine you had like, I don't know, 4 or something, and they all had specific things where traits can be applied. It gets kind of messy to read if it's like this, okay, because you're having to have like a really long kind of thing in brackets, and then you also have the additional factors, the additional things before that to say what each one has to have implemented. It can get messy. So you can also use this where keyword, and I formatted it as well so it looks nice and neat. And this does exactly the same thing. So but sometimes people find this a bit easier to read. I do think it probably is slightly easier to read. We're just saying we've got this function. Again, it's exactly the same functionality. It takes in a T, it takes in shape, which has T implemented, and we're saying T means that this trait is applied and this trait is applied. Okay, and it does exactly the same thing. It's just an easier way to write it and to read it. And to be honest with you, once you get up to, I'd say even more, like if you have 2, and certainly if you have more than 2 arguments going into a function, definitely use where if you're applying traits or, you know, having restrictions on traits. It just makes it a lot easier to read. And you just got to remember, like with all programming, most of the time you're reading other people's code rather than writing code. So just make it easier on yourself and other people. Cool. And this is an example where we might do this. This is not something which would work. I just made this up. But if you wanted to have more than, one argument, in this case, a shape and serialize, we can pass in 2 different conditions. So we can say shape has to have T, and T has to have shape and parameter. We've already seen that. And then U has to have the serialized trait applied. And yeah, that is one that you can, in fact, I think that probably, we're going to come across serialize in the future. Serialize is a trait, I think it actually has a Z in it, but this is just an example, okay, of what it would look like. And you can see that it's much easier to read. Cool. So traits allow us to define our functionality. They're very similar to interfaces in object-oriented programming, and they allow us to surgically apply functionality to different structs, structs being objects and classes in other languages, depending where you come from. It's like a very sophisticated way of doing object-oriented programming, and it can cause some problems, especially for beginners. But if you look at anything on the Rust standard library or in the Rust book, you'll see that once you know what you're looking for, traits are actually used all over the place. And it is because they allow us very like surgical precision on how you define functionality. And then we covered how you can use traits as parameter types. We went through that example with the shapes, circle and square. Okay. So I'm just going to pause now, and then I've got a couple more slides to talk about in terms of advanced functionality, but I'll pause now, stop sharing my screen in case there are any other questions. Otherwise, we can go on.
Just hopping in, Caroline, to say thank you. It's so you detail things so well. Yeah, please, if you have any questions, everybody, do just hop in. No question is not allowed. Really, whatever level you're at, whether you're right at the beginning or further down the line. I know, Caroline, we have a few things of kind of what we can dive into to learn more about this afterwards, but maybe I'll ask you that once we finish the presentation.
Yeah, no problem.
Very nicely distilled and presented.
Yeah, thank you. That's very kind of you. Yeah, so it is a bit confusing about I'm just flicking up about the type. So it is so if you write a different, let me see if I can get something up actually to make it easier. So if I share my screen again, I'm going to do some live coding, and this probably will completely fail because every time I live code, something bad happens.
I love it. Every time people are like, we'll do live coding, I'm like, okay.
I know.
Okay.
It's like saying Russian, isn't it? So
we're giving you the thumbs up. We believe in you.
Or not. Okay, so say you had a function, probably if I just get rid of all of this. Okay. So if I had a function, actually, let's just do one which had again, calculate age. Okay, all right, and I have like a date of birth. I'm not actually going to work this out, but say I have a string and it's a date of birth and it gives me an age. Okay, so it's trying to be helpful. Okay, and we'll just add in some functionality here. So just pretend that it's calculating it. Okay, here I am passing in a type. So to your question that we got in the chat, we are passing in the type here. Okay, so this doesn't have, when you don't have like this and some, like this, for example, you can just pass in the type here. But what we're saying is much more sophisticated. We're saying we want, and I'm just going to pretend, date of birth now can calculate shape, but we're saying instead of saying this is a string, we're actually going to pass in any object which implements the trait shape. Okay, and then we can build up from there. Okay, so it's slightly different. If you get these not brackets, I know what you call them, but the square or triangle brackets, then yeah, that's how you would use them. Angular brackets, there you go. I knew someone here would know. Okay, any other questions before I go on to like a couple of cool examples? Yes, exactly. So trait is used as a type here. Good question. A good statement. That's true. Okay. Right. Again, I'm not going to be able to see you, so make a noise if. Okay. Can you see my screen? I'm assuming you can.
Yeah.
Okay. Cool. All right. So this is an example from my company, or Yellowbird. We make medical simulation software. I run it with Max. This is a really simple example of, we want users to be able to create user accounts. Okay, so they fill in their email and some information about who they are. They give a password, and in our database we store that information, but we also get an ID of the user. They get a unique ID. That's something which is important for you know, if you need to reset your password, you'll need that unique ID, and then some other information like, are they an admin? Have they been blocked? When were they created? So we have a system in which you are creating an account, okay, and what gets returned at the end of that is a user. So you get the user serialized back to you, and that is, so, you know, in the next stage, it will say something like, oh, so if I've made an account as Caroline Morton, I will then get a message on the screen, which will be like, thank you for making your account, Caroline Morton. Something has been sent to your email. Okay, so we're passing back the user. But we don't want to pass back the password. You can imagine that would be a total security nightmare to pass back even a hashed password. So we want to get rid of that. Okay, so we are going to be passing back something which is serialized, and serialization is a way of, and I've written it down just so I got the definition right, it's a way of converting an object into a format that can be easily transmitted or stored and then reconstructed later. So for example, through an API, in our case, we're going from a Rust backend to a TypeScript front end. So we're doing that connection via serialization. Okay, so that's our user. And there is this thing in the standard library called serialize and deserialize. And if you read any Rust, you'll see it all over the place because it's such a common problem. You want to send information between different things. And you can serialize pretty much any struct, and it will probably do something vaguely sensible. Okay. In our case, what we've done is we've taken that trait serialize. So I have created serialize. It's something which already exists in Rust, but we're essentially overwriting it. So serialize is the trait name, and it has this functionality called serialize. Okay, and we can return it returns some results. Just ignore what that is, but essentially it returns like an OK or an error. And we've overwritten this. So we have taken each of the field except for password and serialized it bit by bit. So now whenever we use this user and then serialize it, it is returning a user without the password. Okay, so that's something that we've used in production. This is in production right now. And for obvious security reasons, you don't want to return a hashed password. So the reason I bring this up is because you may not realize from the like very simple toy examples that you see whenever you look up at anything on traits, that it's like hard to think of a use case for it. And this is like something that we use all the time. And I also wanted to bring it up because there are tons of traits in Rust that other people have spent a lot of time thinking about optimizing. And sometimes you want something that is pretty much the same as what they've implemented, but with a slight difference. In this case, serialize. And you can just modify them. That's, to my knowledge, extremely difficult to do in other programming languages. I think if you were to do it in Python, there would be like lots of hacky ways, but you would probably end up just avoiding kind of the messiness of like partial inheritance. You would probably just like copy and paste the implementation of it and then overwrite the bits you want. And then that gets like terribly messy. So you pretty much wouldn't want to do that. So this is an absolute lifesaver for certain things. Okay. So that's one thing, cool feature. And then generic traits. So this is something which I deal with a bit more because I'm dealing with NHS patient data, which sounds like it would be really well organized and structured, but isn't at all, and comes in all different formats. At the last count, I had 14 different implementations of how date is like structured in NHS data. So yeah, you have to sort of do a lot of data cleaning. But I'm imagining in this scenario, we want to calculate the age of patients, and we have two sources of information. So we have from an API. So imagine that goes to some sort of NHS database and returns the age directly. But we also have patient questionnaires where people have been asked to tick, like, which age group do you belong to? And in both cases, we want to do something like calculate age, but you could see that there would be a problem where it would return, in one case, it would return a number, an integer, like 29, but in another case, it would return a string like 26 to 35 years old. Okay, you can see that down on the bottom right. And so this feels like initially impossible to do with a typed, like compiled language, because it would just say like, what do you want, an int or do you want a string? But we can use this thing called generic types to sort this out. And this is a trait that's defined with one or more generic type parameters. Okay, and that allows us to have polymorphic behavior in like a type safe way that the compiler won't get unhappy about. And it's very useful. I make a joke that the compiler is like, oh, it's always unhappy about stuff, but actually it's very useful. So in this case, that's our data structure. We can then do a calculate age trait. And now instead of us returning like a I32, we're just returning a T. And again, I've picked T just generically. It doesn't really mean anything. And then for the patient API, just returning it as a number, an int. And then in this one, I'm returning it as a string. Okay, and that's because this T is like a generic thing and it's in the angular brackets. Okay, and we're in here, we're matching and we're just returning a string. Okay, so that's really cool. Definitely worth reading about generic traits. Once you get into traits, they're extremely useful and very useful if you're dealing with any kind of like messiness or messy data. I just wanted to go have a think about how you design a program that uses traits. I would basically just start with a whiteboard, like what structs do you think you need? What functionality do you need right now? And is there any of that functionality which is shared? And just try and like put it visually onto some sort of diagram. And then what might you need in the future? And then when you have all of that written out, then try to think, are there any traits that already exist, like the serialized one, that you might want to use and you might want to just modify? And then you should be able to like essentially try and structure your code just by thinking about the big picture to start with.